So what I'm going to do, put your phones away, please. Everybody, thank you. So I'll go through the review. I'll write the correct answers on the board. That way they're on the video. And then if you would like to see one worked or you have a question about one, you have an opportunity to ask. Once we get all the way through the review, that's it for the day. You have your quarterly test on Monday. Your QCA 4 is on Monday, so make sure that you remember to use this review as kind of like a study tool, probably Sunday evening to get time to kind of take a look at it. This is a great review for the test. If you're solid in the review, you'll be solid in the test. Okay? So once we get through with it, if you'll just make sure you straighten everything up at the desk, y'all can chill the rest of the. No, I think a lot of people are just going to play chess and kind of vegetate for a moment. Okay? Yeah, vegetate. It's a verb. Alrighty. So based on what you know about this, guys, it's not based on what you know about slope. What does the slope of the graph below represent? Well, when we think about slope as rise over run or change in y over change in x, then basically we're saying that the water level is changing in certain amounts of time. That the water level is changing in certain amounts of time. So one way to put it would be that the pool, remember the y-intercept is where we start. So this thing started at 10 gallons, and it is increasing at a rate of 5 gallons per minute. It's increasing at a rate of 5 gallons per minute. Okay? Any questions on that? Number 2, we have 9, 14, 13 as the median, and 4 as the interquartile range. Okay? Now, the rotations I want to talk about, because on the original review, I did not have a correct answer, and I've changed it since on this, but if you rotate something 270 degrees clockwise, if you think about that, then basically assume we're starting here, then 270 degrees clockwise lands it there, okay? Which is a change from xy to negative yx. Now, does anybody not remember the rule associated with clockwise or counterclockwise rotations? Did it?
Well, why would you negative yx? If it's negative y, wouldn't the y be below the x-axis?
No. Let's talk about how you apply the rule. Okay? First of all, if we're talking about rotations, we are going to always assume counterclockwise. The rule applies to counterclockwise, and then it can be then applied to clockwise based off of how it all moves. So there are basically 3 moves. There's a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. Okay? Now, the way that I use the rule is I use the rule this way. Brendan, are you on the phone? Because I see your face glow. Let's put it away. Thank you. We assume that we start off with an ordered pair of x, y. Now, here's the way I do it. Number 1, for both 90 and 270, I know that the x's and the y's switch places. Claire? I know that the x's and the y's switch places. So in both cases, the x's and the y's switch places. In the case of the 90, the first one changes its sign, and on the case of the 270, the second one changes its sign. And then for the 180, they stay in the same order, they just both change values. Now let me show you what that looks like from an application standpoint. Say you start off at the point 2 to negative 3. And I say, okay, we're going to rotate it 90 degrees. Well, the very first thing you think of is, okay, wait a minute, 90, they switch places. So it becomes negative 3, 2, right? The first one changes its sign. So it goes from negative 3, 2 to 3, 2. That would be a 90-degree rotation. If it was a 270-degree rotation, again, and don't try to do them both at the same time. Do it as a 2-step. Switch the places. So it becomes negative 3, 2. And on the 270, the second one changes its value. Negative 3, negative 2. Get it in? That's the way I want you thinking about it. And by the way, 180 for this would be -2, +3, because they both simply change values the same in my order. And if you think about a 90-degree counterclockwise rotation, that would be the same as a what counterclockwise?
270.
270 clockwise, 180, and 90. Okay? Then you're still looking, sorry.
So the same rule applies for clockwise?
Well, watch. If my point is 2, -3, it's basically right here, agreed? If it goes 270 degrees counterclockwise, that is the same as 9 degrees clockwise. You end up in the same place. It's a circle. Okay? All we're really talking about is the direction that you're going.
Oh, I understand now.
Okay? But what I'm saying is the rule applies to counterclockwise. That's how I remember the rule. Not just use it for clockwise if I need to. Okay? Any questions on that? All right, so here we go. 4 is 512 pi cubic inches.
Yeah.
We don't really need that, thank you. Number 5 is 17.63 repeating. Pay attention. Gotcha.
Would it be 17 and 7/11? Yeah.
Yeah, same thing.
Yes, I got it right. You got it wrong.
Okay.
Okay.
It's me talking while I'm trying to go through the repeat, Jackson. So let's not, cast stones if we live in a glass home, shall we? Thank you. So, x plus 4, y minus 3, x minus 2, y minus 1, x, y plus 4. Any questions on those? Labib?
What if you do 4 plus x? Will still be right.
Yeah, but you'll never see it that way on a test. On a multiple choice test, you'll never see the number first. Okay? But yeah, mathematically it's the same. What similarities do they both have? They are both linear. They both form a line. And the difference is that, and by the way, I want to be real clear on this. A linear relationship does not necessarily have to go through the origin, but it can. But it has to be straight. A proportional relationship must be linear and must go through the origin. And I've seen kids before, by the way, who will tell me that y equals 3x is proportional but not linear. That's not true.
Yeah, proportional.
Okay?
That's really.
Yes, ma'am.
I was just gonna say if we
Well,
put
to be
19.6,
proportional has
is that
to be
okay?
Exactly.
If you said 17.6, it depends on what the, if it's agreeable, it says around the hundredth, I'd say no, but yeah. Okay. Alrighty, almost done. So on 8, line A, for line A, we start at the y-intercept of 3 and we go down 2 over 1. We graph it that way. For line B, we start at y-intercept of -2 and we would go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1. If I said what ordered pair satisfies both equations, you're looking for where they intersect. You're looking for where they intersect.
0, 3.
Okay? Number 9. This is uniform, this is skewed left, and this is symmetrical.
No way.
Okay? Jackson, I'm really done with this while for months. Thank you. Just hold on, and then we'll be done. Got it? Good. Number 10. Anything that's a cubic function is going to be nonlinear. Anything with an exponent is going to be a nonlinear function. Bennett?
Didn't they say anything for the exponent? Wait, what would a line look like to have an exponent?
It'd be.
Depends on the exponent.
What if it was 2 1?
This is a squared function. This is a cubic function.
Oh.
Oh, because if you 3 or 2.
Because.
And by the way, they can also, this could also be reflected down, and this can also be flipped as well.
Wait, no, it's actually no cubic feet
That's
the other way.
not a cubic function.
Wouldn't it be
Yeah.
Because on the negative side, the negative x side would be a negative y.
Oh,
Oh,
wait, stop it. You're gonna hurt yourself. Okay? Okay. All right, number 11. This is the only one that represents a function. This fails here, this fails here, and this fails here. Okay?
the one on A feels twice.
Yes, it does. Number 12 is 1/30th.
Oh yeah.
Number 13 is 96 square centimeters. I didn't see any of those. Everybody good on all that?
Yes, sir.
Good. And finally, 14. Y equals 1/4 x minus 1.
Yep.
You would plug in the x value of 14, you get 2.5, and you get 20. Make certain you can draw a pie chart based off of percentages. You have to first find the percentages. The total here was 40. So once you set up fractions and found the percents, this was 20%, this was 40%, this was 15, and this was 25. Now, whenever I'm drawing percentages, I would start with the one I absolutely know. The 25 is probably the easiest one to know, so I would have started with that and made that copy. The 40% is going to be a little less than a half. So if you assume that the half goes here, you just cut it down a little bit, and that would give you soda here. And then you simply skew the remaining two, which are 20 and 15, in half, but then skew it a little bit. So this would be milk, and this would be H2O.
That's what mine looks like.
Okay?
Looks like 4TO. 4TD. We got another page too. There's another page. No, there you go.
Finally, 112, 118. Alex, Jack, remember the test? Remember the test is y divided by x. If y divided by x is constant, except with regard to the origin, and it's proportional, and these k was 3/4 every single time, that made it proportional. The constant of proportionality was constant. Okay, that constant of proportionality was constant.
This one was
No, really wrong. No, because the if in there makes it
Because it can either be if this one was dilated or if the figure down low like is dilated.
it is the one.
No, if it
If
said,
the figure is dilated by the scale factor of 1/2.
if it said had been, that would be a past tense use of the verb.
But it says if the figure below is dilated, which it's already dilated. No, it's not.
No, it's not. It's genuinely not in any way. If it said, Brendan, I want you to understand, if it said, if the figure below has been dilated or is the result of a dilation of whatever, that's one thing. But if it tells you this figure is dilated, what is the area? It's asking you to dilate it and then find the area. Okay? And I'm saying that because if I worded it that way, I made the test too, so, you know. Here we go?
Yeah.
By the way, so you end up with 24 square yards and 6 square yards. Does everybody remember the result of a scale factor on area and volume?
Yeah.
You might want a quick reminder, we good. Take this real quick. Here's the way scale factor works. We know that scale factor changes the shape of something through multiplication. It either makes it larger or it makes it smaller, right? So you have 3 different types of changes that can be made with regard to a shape. You have what's called one-dimensional measurement. You have two-dimensional measurement, which is area. And you have three-dimensional measurement, which is volume. And when you're using a scale factor, if you're going to change one-dimensional measurement, by the way, one-dimensional measurement can be radius, diameter, circumference, length, width, height, anything that's literally a one-dimensional measurement, you take your one initial measurement, you multiply it times your scale factor, and you get your new measurement. Remember, the use of that prime is what tells you whether it's been dilated or moved or not. Brendan and Jackson, last time. I have about 30 more seconds, and y'all could just please pay attention. Okay? Area. You take your original area, you multiply it times your scale factor squared, and you get your new area. And on volume, you take your original volume, you multiply it times your scale factor to the third power, and that gets you your volume, your new volume. And that's a very, very important thing. If I tell you that a cube is changed by a scale factor of 3, and I say the original volume is 12, like cubic inches, and I say, what's the new volume? You multiply it times 3. No. Volume, you multiply it times 3 cubed, which is 27. So, make certain you understand that. Other than that, guys, that is it. If you'll make sure everything is typed up, ready to go, and the test will be on Monday.